Welcome to Emtron Training Part 16. In this training tutorial, we're going to be taking a look at working with our fuel injector characterization data. The fuel injector characterization data is going to make sure that we're representing the flow of the injector, the response of the injector, and any nonlinear type of behavior to the Emtron specific to the injector set that we're dealing with, so it knows how to convert a requested fuel mass into an injector pulse width and properly deliver the fuel we need into our engine. If we don't characterize this properly, we're going to find we have an error within our fuel and airflow modeling relationship, and we're going to run too rich or too lean. We're going to break down how all this fits together within the Emtron programming. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at programming our injector characterization data into our Emtron software. Injector characterization data has to be accounted for and entered in correctly based on the injector set that we're dealing with, because each injector set will have its own unique characterization and response. If we don't get this information programmed properly, our airflow and fuel modeling relationship that we have in our Emtron that's calculating in the background won't be valid, and therefore we're going to have either an over or underestimation of airflow, and therefore it will lead to all kinds of other torque calculation problems as we go down the line in calibrating and tuning with our Emtron. We want to make sure basic details are accounted for, and the injector characterization is going to be one of these basic essential details. Last video we were talking about our ignition coil dwell and how that was very important to be able to make sure that we're having proper charging and the spark energy in our system, in our ignition system. We want to make sure that same kind of concept here is applied to the injector characterization data, because it's unique to the injector set that we're working with, and if we don't represent that accurately, again, our air and fuel modeling relationship will be thrown off. So let's go in here and talk about the basics here in the beginning of the video, and then we're going to be talking about the individual areas that we have to program and how they fit together into correcting the injector pulse width. The first thing we need to understand is that there is an underlying equation here that's going to represent all of the calculations that are being performed in the background for delivering the fuel to the engine. And that's going to be fuel mass is equal to air mass divided by target air fuel. Now, this might seem complicated. Let's break this down of how this all fits together. In our Emtron system, we have the ability to either work with a MAF sensor or speed density operation. In our mass airflow, we'll be having a MAF sensor report back to the Emtron either a voltage or a frequency signal that we can then go into a lookup table and figure out what the air mass is being ingested into the engine. We have to know what the air mass is so that we can determine what kind of fuel we need to deliver in response to that air mass. Now, what we're going to find is that in this particular example that we're looking on screen right now, we have the ability to estimate the airflow. If we want to get rid of the mass airflow sensor and we want to work with a map pressure speed density type of operation, we're able to do that. It simplifies the airflow modeling, so to speak, so we don't have the constraints of a MAF sensor that can give us skewed results sometimes. And we'll find in this situation of estimating the amount of airflow in this speed density operation, we need to account for a couple different variables in determining air mass. So we have, again, that air mass that we have to figure out. Either we're measuring it or we're directly calculating it. So speed density, in order to figure out air mass, we have to figure out volume and the density of air coming into the engine. When we have a mass airflow sensor, we're counting for both volume and the density in that particular translation from voltage or frequency as the signals coming in from the MAF, and then determining the lookup for the actual air mass. But in this particular example of speed density, volumetric efficiency, we're going to have to do some estimation and some calculations of what that's going to be. So the volumetric efficiency table here represents the estimation of cylinder filling, or the percentage of cylinder filling that we have with our particular engine. If we specify the engine displacement, or the total volume of air that can be ingested, and then the number of cylinders, and we're specifying the percentage of cylinder filling at a particular load and RPM point, the Emtron can figure out the volume of air that's entering the engine. Now, we also need to account for the density, because with mass and talking about air mass, that's volume times density. We need to make sure we're accounting for both the amount of volume of air coming into the engine and how much oxygen molecules are being packed into that volume of air so that the fuel modeling can be accurate. What we're going to find with the density and calculating the density, we need to know the intake air temperature. We also need to know the barrel pressure. Combine both of those together, we know our density, and then combining what we're estimating for the volume of air here in our VE table, we'll know the volume. So volume times density is air mass. So we can estimate the air mass coming into the engine, or we can directly measure the air mass.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.